Please subscribe, and you can download this code from description below. Python extensions produced by Cython and Pyrex can be made thread safe, but whether they are thread safe by default depends on how you write and compile your code. In this tutorial, we'll explore the concepts of thread safety in Python extensions created with Cython/Pyrex and demonstrate how to make them thread safe with code examples. Thread safety is a property of code that ensures it can be safely executed by multiple threads in a multi-threaded environment without causing unexpected behavior or data corruption. In Python, the global interpreter lock, GIL, often simplifies thread safety concerns, but when working with Python extensions, especially those written in C, you need to consider thread safety explicitly. Cython and Pyrex are tools used to write Python extensions in C or C++. By default, the code generated by these tools is not thread safe because C/C++ itself does not guarantee thread safety. However, you can take steps to make your extensions thread safe. Here's how to ensure thread safety in your Python extensions. Avoid global variables. Global variables can lead to race conditions in multi-threaded environments. Instead, use thread local storage or pass necessary data between threads explicitly. Protect shared data. Use synchronization mechanisms like locks, semaphores, and mutexes to protect shared data from concurrent access. Use the GIL when needed. In some cases, you may need to acquire and release the global interpreter lock explicitly using Python's threading module to ensure that certain parts of your code are executed atomically. Design thread-safe functions. When designing your extension, encapsulate the functionality into functions that are thread-safe by design. Avoid shared mutable state whenever possible. Now, let's see some code examples to illustrate these concepts. In this example, we'll use the threading module to protect shared data with locks. In this example, we use a lock to ensure that only one thread at a time can modify the shared _data variable. In some cases, you might need to explicitly release the GIL to allow other Python threads to run. Here's an example. In this example, we release the GIL using thread1.join, to allow thread 2 to run simultaneously. This can be useful when you have CPU-bound tasks in your Python extension and you want to maximize CPU usage by allowing multiple threads to run concurrently. Remember that releasing the GIL can lead to complex interactions between threads, so use it with caution and only when necessary. Python extensions created with Cython/Pyrex are not inherently thread safe, but you can make them thread safe by following best practices and using synchronization mechanisms when necessary. Keep in mind that writing thread safe code can be challenging, and it's important to thoroughly test your extensions in a multi-threaded environment to ensure their correctness. ChatGPT